And the first one I want to make sure we go over is number 8. So if everybody could look at number 8, please. It says the function f is given by, and then this is your function, and then the derivative is given by, and they give you this function. So this is f of x, and this is the derivative. It says write an equation. Okay, so guys, what 2 things do I need to write an equation? Perfect, good. Point and slope. So I need a point and I need a slope. And they're going to need to tell me where to write the equation, where my point of tangency is. So it says at e to the 4th. So the reason I wanted to definitely make sure I went over this one, this problem is not necessarily hard. It just looks really, really, really strange with all the ln's and the e's and everything everywhere. So I just wanted to make sure we went over this. So to get the point, I'm going to plug e to the 4th into f of x. Just plug that into the function. So if I plug that in, I'm going to have 1 plus ln e to the 4th over e to the 4th squared. So that looks awful, but ln and e are going to cancel. And so in the numerator, you just have 1 plus 4. So our numerator is just 5, and our denominator, when you do a power to a power, you multiply them, so that would be e to the 8th. So 5 over e to the 8th. That is some decimal. E is a number. E is 2.718, da 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 da. So this is some number. I just, without a calculator, I don't know what it is, but good enough. All right, slope comes from the derivative. So we want to plug e to the 4th into the derivative. So I'm going to plug e to the 4th into this gigantic mess. So that's going to be negative, parenthesis, 1 plus 2 ln e to the 4th over e to the 4th cubed. So once again, ln and e are going to cancel. In the numerator, I've got 1 plus 2 times 4. Okay, 2 times 4 would be 8, plus 1 would be 9, and I'm going to make it negative. So my numerator is negative 9, and then down here, when you do a power to a power, you multiply, so that's e to the 12th. Again, this is some number. It is just a value. So that's my point, that's my slope. And I'm going to put it together into an equation. So it'll be y minus 5 over e to the 8th equals my slope, and then parenthesis x minus e to the 4th. So it looks real dangerous, but the most math we did was 2 times 4 and then plus 1. I mean, there's not very much math in it. It just looks really, really scary. So you plug into the function to get the point, and you plug into the derivative to get the slope. The other one that I wanted to make sure we went over is number 11. So if everyone could flip to number 11. You did this on your quiz. You're going to do it again on your test. It's just a lot of algebra steps. So I wanted to make sure that we went through it again together in class. So using our definition of a derivative, you have to put limit. It's limit as h goes to 0. That's the only thing that makes it calculus. The rest of this is just a big bunch of algebra. And then we're going to plug x plus h into the function. So I plugged x plus h into both of those x's. Oh, whoops, didn't mean to write on there. And then I'm going to subtract the function. So I'm going to subtract f of x, and then that is all over h. So there's going to be this one step where this is really annoying. We're going to have to expand this all out. But then after that, stuff is going to cancel. And it's almost self-checking, because if stuff doesn't cancel, then you'll know you had a mistake. All right, off to the side, I'm going to do the x plus h squared. I'm going to do this quickly because we've done this a lot of times at this point. If you multiply that out, it'll be x squared plus 2xh plus h squared. and I have to distribute a 3 into that. So that'll be 3x squared plus 6xh plus 3h squared. Again, it looks like a lot, but it's just a bunch of distributing. I believe in you. That's my pep talk. Go team, you can do it. You're just multiplying a whole bunch of stuff together. So then I'm going to distribute this -8. And then -2 is kind of just there. And then distribute this negative, so -3x squared plus 8x plus 2. Phew, we did it. Now, a lot of stuff should cancel. All right, so guys, what do you see that is going to go away? Because hopefully a lot. All right, good. 8x's are gone. And the 3x squareds are gone. And there should be something else. Good, and the 2's are gone. So everything that's left, there's only 3 terms left. They all have an h in them. And so we're going to factor out an h. Don't skip this step, because if you skip writing this, you're going to probably lose part of your answer. And you guys listen to me on the quiz. I already wrote out this step. If we take out h, we're going to be left with 6x plus 3h minus 8. H's cancel. And then here is our answer. Here's our derivative. We're going to plug 0 in for h. So that term's going to be gone. And we just get 6x minus 8. I'm going to go ahead and do B just since we're right here and it goes together. But those were the 2 I wanted to make sure I did, because that's a lot of work. And I don't want anyone to miss this. It's a bunch of steps, but it's not necessarily hard. You're just distributing and canceling things out. So I want this to go well for everybody. Let's just go ahead and do B since we're right there. Write the equation. So we need a point and a slope, and our point needs to be at -3. So to get the y value for my point, I'm going to plug -3 into the function. So -3 squared will be 9, times 3 will be 27. -3 times -8 will be positive 24. And then -2. So, oh my goodness, what is that? That would be 22, so 49. And then slope comes from the derivative, so we're going to plug -3 into the derivative. So if I plug in -3 right here, that'll be -18 minus 8, so -26. And then just put it all together in your answer. Y minus 49 equals -26, parenthesis, x minus -3, so x plus 3. And please don't rearrange that. I know we had to for some of the multiple choice questions. Mine's not multiple choice, so please just stop. Just leave it alone. All right, and I will now proceed to answer as many questions as I can in the time that's left. So you guys just type them in the chat, which ones you want, and I will go over them for you. All right, 1. So a secant line means that it should hit the graph in 2 places, so it's over an interval. And we're just going to show these types of average rate of change. This is basically just to get you a visual of this. So I'm actually just going to draw a parabola for all of these, just to keep things simple here. You could draw something real complicated if you want it. I'm just going to draw a parabola. So if we want a positive secant line, that would be something like this, a positive slope. This would be a negative secant line, negative slope, and 0 slope would be a horizontal line. So something like that. So just remember, it all boils down to slope. That's really what is going on here. If you get to a problem that you're stuck on, just try and do a slope, because that's probably what it is. And I did number 8. That was the first one I did. All right, so what else would you guys like? All right, 16. And someone asked if you didn't draw the parabola, but you just drew a line. That's okay. You just kind of didn't draw a graph that went along with it. But if you're showing me you understand what positive slope and negative slope and 0 slope are, then I'm happy. Is that enough time? Okay. All right, so 16, we want to know where this function is differentiable. So first we need to see if it's continuous. So let's plug 4 in for both of these. If I plug 4 in here, I'm going to get -4. And if I plug 4 in here, 4 minus 4 would be 0, minus 4 would be -4. Okay, so I get -4 for both of them. So I know that the two pieces meet up. To check if it's differentiable, I need to check the slope from each side. Now the first one, that's linear, so I can actually just use the slope. The slope for that is -1. I need to see what the slope from this side is. So it is going to be limit x goes to 4, and then it is the function. Now I'm going to need to multiply this out. So off to the side here, let me multiply out the x minus 4 squared. So that would be x squared minus 8x plus 16 for this x minus 4 squared. So then if I take away 4, 16 minus 4 will be 12. So I've got x squared minus 8x plus 12. So that is the function. And then we want to subtract whatever we get when we plug 4 into the function. Now, when we plugged in 4, we got -4. So this would be minus -4, which is going to be plus 4 over x minus 4. There were just a ton of 4s in this problem. So 12 plus 4 takes us back to 16. So here, I'll write this out here. So it'll really be x squared minus 8x plus 16. And then we need to factor that. So that is going to split x minus 4, x minus 4. Just like piling on the 4s in this problem. So these cancel, and if you plug in 4, 4 minus 4 gives you 0. So that means that the slope from this side was 0. And the slope from this side was -1. So we are not differentiable at 4 because the slopes from each side were not equal. This one was -1 and this one was 0. So where is this function differentiable? Everywhere else except for 4. So all x except for 4. And again, it's really difficult to be differentiable with a piecewise function. Continuity is easy. You can just make them meet up. It's really hard to get those slopes to be equal. All right, NCJ, I saw what you wrote. I'll talk to her later. Thank you for letting me know. All right, again, I will do as many of these as I can. So what else do you guys want? All right, 6. So this says, find the slope of the line tangent to that graph at 2. So slope of the tangent line means the derivative. We want to find f prime of 2. So that is actually the same formula that we just got done using. We're going to practice it again. So limit as x goes to 2, and then it is the function, so 2x cubed, minus whatever you get when you plug in 2. So let's see, 2 cubed is 8, and then double that is 16. And then it is over x minus 2. So factoring, we're going to have to factor a 2 out of the numerator. So that would give us x cubed minus 8. Ooh, and we're going to have to factor the cubes. We'll see what you guys remember from this. Do you guys remember how to factor cubes at all? Does anyone remember how to do this? Yes? Do you remember like same, opposite, always positive? That's how you remember the signs for it? We're going to cube root both of these, so it'll be x and 2. I would normally ask you guys to like help me out with this, but it's difficult when you're trying to type it in a chat. All right, and then you square the first term, and then multiply them together, so 2x, and then square the last term. It's square multiply square. And then your signs are same, so the same is what was in the problem, opposite, always positive. All right, so that is your factoring of cubes, and then the x minus 2's cancel. And we are going to plug in 2. So 2 squared is 4, plus another 4 would be 8, plus another 4 would be 12, and then don't forget to times it by 2 out front. So 12 times 2 would be 24. All right, what else? You guys can just keep typing questions to me, and I'll keep going over them. I'm going to do as many as I can. All right, 10. All right, for 9 and 10, we're using this chart here, which is great because all the numbers that you need are going to be right there. For an equation, we need a point and a slope. So the point is going to be 2 something, and we're doing the tangent line to f. So I need f of 2. So here's the f column. F of 2 would be 4. And then the slope comes from the derivative, so I want the derivative at 2. And this is my f prime column, so my derivative at 2 is 0. And then just putting it together into the equation, it'll be y minus 4 equals 0, x minus 2. Yes, I do realize that the entire right side of that equation would then be 0. But what if it wasn't 0? Say it was some other number, then you'd have to write it out. So I like to just be thorough and write the whole thing. All right, what else? Or do you want me to pick one? Or are you guys good? I'm gonna need more from you. I pick, okay. Let me see what I think would be the hardest one. Let's do 14. Or, oh, someone said 20. We'll do 20. What are the critical values of f of x? So here's our graph for f of x. We're going to have a critical value here. So -2. And then also here, I meant for that to be on 0. It's off a little bit. Just pretend it's at 0. So those are your critical values. Why don't I just go through all these since we're here talking about this graph? On what intervals is f of x positive and negative? So positive means above sea level, negative means below. So positive would be -∞ to -3, and then also -1 to 1, this little piece where it's above the x-axis. Negative would be below sea level, so that would be -3 to 1, and then also 1 to infinity. 19 is asking, on what intervals is the slope of the tangent to the graph? Now, slope of the tangent line means derivative. This means derivative. So where is the derivative positive and negative? All right, the derivative is positive where this graph is increasing. So this graph is increasing from -2 to 0. And the derivative is negative where this graph is decreasing. So that would be -∞ to -2, and then also 0 to infinity. And then this last one, on what intervals is the derivative increasing and decreasing? What I would do is graph the derivative, just graph a sketch of it. We would have critical points at -2 and 0. And we would want to be below, above, below. So I'd want to be below the x-axis, and then above, and then below. So this question is asking, where is this graph increasing and decreasing? So this graph is increasing from -∞ until -1, and then decreasing from -1 to infinity. Okay, all the notations for a derivative. Now, I wouldn't ask you a question on the test that was like, state all the forms of notation. The reason I put that on the review is, no matter how it's written, I want you to know what a derivative notation is. So that was number 4A. So F prime is what you're going to see most often, but then you can also see Y prime or dy dx. So all of those things mean derivative. And again, I wouldn't ask you that like as a question outright, but no matter which one of these is written, you need to know that that means derivative. All right, 17. All right, a function will not be differentiable if it is not continuous, if you have sharp edges, or if you have a vertical tangent line. And so discontinuities would be things like asymptotes, holes with a point somewhere else, and jumps. Those are all your kinds of discontinuities. Sharp edges would be corners and cusps. And a vertical tangent line would look like this, where the graph kind of goes vertical in the middle. All right, so maybe one more. We've got these derivative graphs on the back. Do you want me to do those? I was thinking either those or gosh, I can't remember what the other one was. I'm going to post the key as soon as class is over here. At least one. These will be real quick. I mean, these don't take long to do. This first one, we've got a critical point at 0. And my graph is increasing and then decreasing. So I want to be above. Do you guys remember me doing the color coding for this? You can color code if you want. We want to be above and then below. So above the x-axis and then below. This one is going to have critical points at -2 and at 4. And we would want to be above, below, above. So above the x-axis and then below and then above. And again, I don't know how far down this goes. The only particular points we got are the critical points. The rest of it is like good enough. And then here we're going to have a jump at 2. We're not differentiable here because of the sharp edge. So my slope is going to be -1 until I get to 2, where that sharp edge is, and then +1 after that. But you can't get a derivative there because of the corner.